Hi, welcome to Einsrodinger. In today's video we're gonna see how behaves the fourth dimension in the theory of relativity. We saw in last video how the closer we get to the speed of light, the more different is the combination of the three classical dimensions from the expected value. And is in the speed when we can find some ideas in order to find how, where is this fourth dimension. Because speed is the relationship between the space, understood in a classical sense, and time, of which we have not to speak yet. This way, in order to define a mathematical distance, we have to use both the three classical dimensions and time. From now on, we cannot define points just like location in space. We have to use events. Events have both a location in space and a position in time. For instance, we could define an event like the click that we have made in the beginning of the video, and another event could be another click, like this one. Between one and another, there's a classical distance that we can measure just like in the first video, and a time distance, that is just the time that has passed between one and another. And experimentally can be seen that there's a relationship that is always the same no matter the state of movement of the observer, and we saw this is the main condition in order to define a mathematical distance. Let's make a triangle where one of the shorter sides is the classical three-dimensional distance between events. If we make the distance that lights travel in the time between events the hypotenuse, then the other short side will always be the same for all observers. Let's imagine two people watching this video in two different conditions. One person is watching this video with the screen standing still. From first event to second event, we'll measure this spatial distance. If there's another person whose screen is moving to the left, we'll have a different distance, because the first click will be seen here and the second point will be moving to the left because the screen is moving. So the second click will be seen more or less in that direction and the length will be higher. Let's take this as the measurements done by the observer with the screen standing still between both events. If we want to use the distance measured by the observer with the moving screen, then this side will become larger, but the other side will have to remain the same. So the hypotenuse will also become larger, and due to the fact that the speed of light is the same for all observers, and we will explain this fact in another video, a larger travel will imply a longer time. The reason why in our daily lives we cannot measure this difference in time is because the speed of light is really high, 300,000 kilometers per second. In our daily lives, the speeds are much slower. We consider slow anything below 100,000 kilometers per second. So when we are in a slow speed, when we make the triangle, this superior short side will be small. We can see that for small speeds, we will see the hypotenuse will change, but the variation will be really small. So from one observer to another observer, the measurement of time will be almost the same. We will begin to make a difference when the speed becomes higher. In this case, the higher short side will increase and the hypotenuse will increase too. And in these cases, we will be able to measure a difference in time. So we can see that this space-time distance will be generated by three dimensions of space that will be in this short side, and one dimension that will be on the hypotenuse. When we combine all four together, we get the 4 dimensions of space-time. These ideas, of course, have to be thought carefully, because they don't represent our daily life and they are not easy to assimilate. But our models are always a way of reflecting of daily life, and our daily life is always the speeds much slower than light. So now we have to make an effort to create new models that adapt to our new experiences. Let's keep on thinking.